lectures. Okay, so good morning, everyone. Good morning, Caraga. Good morning, participants. Welcome to CSU e-PASA Lectures 2020, webinars on techniques and strategies in teaching statistics and probability. By the way, I am Milburn O. Macalos, and I am your facilitator for this webinar. So before we start our webinar, let me uh, remind you of the following house rules. Number one, have your phones on mute. Number two, the use of laptop for this webinar is recommended. Number three, have the notifications from your phone, tablet, or any gadgets be turned off or on mute. Number four, prepare a pen or a marker and sheets of paper. Use the chat box for your questions, which will be facilitated after the lecture. And lastly, we have, if you experience interruptions, kindly refresh the page. So it is my privilege to deliver to you the message of our CSU Vice President for Research, Innovation, and Extension, Mrs. Rowena E. Varela. The world has caught off guard when COVID-19 strikes in the early 2020. The spread was so fast that nations around the world have to initiate quick response programs to ward off the impact of COVID-19. After 3 months, the pandemic still continues to threaten the nations. However, people around the world start to develop adaptations to the new normal. The Caraga State University is with the world in developing adaptive mechanisms to continue to be relevant in the new normal scenario. For one, the CMNS and the CHAS, formerly the College of Arts and Sciences, created the e-PASA program to continue to serve its clients. The e-PASA is the online version of the extension program of the college, which is the PASA, which literally means to pass on the knowledge in the science, math, and the arts to the basic education providers in rural communities. Under the new normal scenario, the new normal approach utilizes the online platform to reduce the possibility of COVID-19 contamination by eliminating congregation in one area. Through the e-PASA, we look forward to continue serving our clients in passing on the knowledge and skills. With the new normal, we hope that this online platform would give an added knowledge to our clients by realizing that the learning is possible even if threatened by disasters and diseases. Okay, so uh, stop sharing. Okay, so to continue, before I will introduce our speaker for today, let me quote or let me say this quote from Albert Einstein. He once said that in the middle of difficulties lie opportunities. We all experience difficulties in our lives. However, what makes some of us different from others is how we deal with the problems. Okay, so with the problems, and the person that I will introduce to you sees difficulties as opportunities. Our speaker for today was once a student of Caraga State University main campus, and she graduated BS Mathematics as the class valedictorian of 2014. She earned an academic award as magna cum laude and was awarded as one of the top students in Caraga region. This is obvious because when I researched her records on my employee's account, she was a consistent dean's lister. She also finished her master's at Caraga State University, and at present, she is excellently handling the senior high school students, sharing her knowledge and expertise with them. My dear participants, please help me welcome Mrs. Rachel B. Apdo.
Thank you, Milburn, for that wonderful introduction. Okay, once again, good morning, everyone. Welcome to the fourth lecture and the last lecture of the webinars on techniques and strategies in teaching statistics and probability. So just a recap, last Monday, Ma'am Permanis talked about random variables and probability distributions. Last Tuesday, Sir Agua talked about the most important continuous distribution, which is the normal distribution. And yesterday, Sir Tinio imparted his knowledge about random sampling and sampling distribution. So in today's lecture, I will talk about the most applicable statistical analysis in statistics. So before we proceed, am I loud and clear? Am I loud and clear?
Yes, ma'am. Yes, ma'am.
Okay, thank you. So first, let's recall the two branches of statistics, which is the descriptive statistics and the inferential statistics. In descriptive statistics, we were taught about the different methods of collecting the data, how to describe the data, for example, the mean median mode, and how to present the data in textual, tabular, and in graphical form. Inferential statistics is the analysis of a subset of data leading to predictions or inferences about the entire set of data. So let me highlight on the word inference. Inference means conclusion that is based on evidence or facts. But before we come up with inference, we will deal with our decisions first. So would you agree with me that we all make decisions all the time, constantly, unknowingly or knowingly, right? So in making decisions, in statistics, it is a vital concept to learn. So the procedure of making decisions in statistics is what we call the hypothesis testing. So as we all know, we have two types of hypothesis. Hypothesis is defined as the educated guess, or those assumptions that may be true or not. So there are two types again. We have the one that is denoted by H sub O, which is the null hypothesis, and the one that is denoted by H sub A, the alternative hypothesis. So some references denote it as H sub 1, so let's not be confused about it. So after making decisions or after making assumptions about the hypothesis, there come up with our confirmation of those assumptions. So what's the process of confirming it? Of course, through statistical analysis. So one of the statistical analysis is what we call the correlation analysis. So here's the outline of the presentation. We already reviewed about the branches of statistics. Then I will review about the levels of measurement. And then we will be guided about these two questions. Number one, what does it tell us? Meaning, what does correlation tell us? So for example, in the measures of variability, what does measures of variability tell us? Of course, it tells us about how spread the data is. So what does correlation tell us? Of course, I will discuss about bivariate data, correlation, and how to describe correlation. Next, how do we find and interpret correlation? So here I will discuss about some bivariate correlations, and I will highlight on Pearson correlation, we will do it manually and using technology. I hope you already downloaded the hands-on Excel in LMS. And then we will use in the analysis the p-value method using technology. So review on the levels of measurement. So there are 4 levels of measurement. First is the nominal level, which is the lowest level that deals with the categories but no ordering or directions. For example, sex. Sex can be categorized according to male and female. But notice that male is not above female, female is not above male, meaning there was no ordering or direction. So if the variable has ordering or directions, we will go to the next level, which is the ordinal level. These are ordered categories, rankings, orders, or scaling. For example, class ranking. So class ranking can be categorized as first, second, third, fourth, and so on and so forth. Of course, it has order because first is first, second is second, third is third, and so on and so forth. But if we find the difference, say second minus first, it does not make sense at all. So if the variable has difference, we go to the next level, which is the interval level. So in the interval level, it can be ordered or ranked. There are difference between measurements, but no true zero. For example, temperature in degrees Celsius. Of course, it can be ordered according to the hotness. Of course, 30 degrees is much hotter than 20 degrees. There are differences because 30 minus 20 is still 10 degrees Celsius. But this time, it has no true zero. So when I say 0 degrees Celsius, it doesn't mean the absence of temperature, but it means that 0 degrees Celsius is the freezing point. So that's the interval level. How about if true zero exists? So we go to another level, which is the ratio level. This is the highest level of measurement. So for example, height. Height can be ordered according to, for example, centimeter, 157 centimeter, and so on. There are also differences, but this time, true zero exists. Meaning, for example, height of the students, when I say zero height, meaning it's the absence of student. So meaning, when you say zero here, it is the absence of object or a thing. So those are the levels of measurement again, the nominal level, ordinal level, interval level, and the ratio level. So let's have a quick test. How about civil status? What is the level of measurement? Civil status can be categorized as single, married, complicated, annulled, or and so on. So what is the level of measurement for civil status? Oh, yes. The civil status is in the nominal level. Okay, how about income? Income is in the ratio level. Yes, you are correct, sir. Jenny, Fritzy, Jane Riza, correct? How about standardized exam score? Yes, it is in the interval level. Of course, exam score, when you say zero, meaning his or her performance is zero. How about socioeconomic status? Yes, it is in the ordinal level. Okay, thank you for your participation. And then we proceed to what we call the bivariate data. So bivariate data are data collected which involves two variables, the independent variable and dependent variable. So meaning to say, when you say bivariate data, of course, from the word itself, bi meaning two, it comes in pairs. So the independent variable is the variable that can cause the dependent variable to change. So in other words, dependent variable is the variable that can be affected or influenced by the independent variable. Let's have an example. The table below shows the number of composition notebooks and the corresponding costs. So the cost per composition notebook is 25 pesos. Which do you think is the independent variable? Which do you think is the independent variable? How about the dependent variable? Oh, so the independent variable is the number of notebooks. How about the dependent variable? The dependent variable is the cost per notebook. Let's have an example again. The table below shows the number of selfies posted online of students and the scores they obtained from mathematics tests. So which do you think is the independent variable? Okay, thank you, Sir Jenny. It's the number of selfies. And of course, the dependent variable is the scores in math test. Another example, the table below shows the time in hours spent by 6th grade 11 students in studying their lessons and their scores on a test. So which do you think is the independent variable? Of course, the independent variable is the time spent and the dependent variable is score. Okay, so let me go back to example number 1. How about we graph example number 1 in an XY plane or Cartesian plane? So let's denote the number of notebooks as X. Usually, X is the variable for independent variable. So, and Y for cost, the dependent variable. So let's take a look at this graph. What can you say about the graph? What can you say about the graph? Would you agree with me that as X increases, Y also increases? Meaning, as the number of notebooks increases, the cost also increases. Okay? And then when we connect the dot, it forms a line, right? And we all know that the line has positive slope. So we can say that direction is positive. And since it is a line, we can say that the graph is linear, right? So it's safe to say that we can conclude that there is a relationship looking visually between the number of notebooks and its corresponding cost. Okay, how about example number 2? We denote X by the number of selfies and Y by the number of the scores in math test. So let's take a look at its graph. What can you say about the graph? Yes, it's decreasing, right? So when we say decreasing, meaning to say as X increases, Y also decreases, meaning as the number of selfies increases, the Y, the scores in math test is decreasing. Okay, and then if we connect the dot, it also forms a straight line. But this time, the direction is negative. But still, the graph is linear. Again, looking at it visually, we can say that there is a relationship between the number of selfies and scores in math tests. How about the example number 3? Let's denote X by the time spent and Y the scores. So let's take a look at this graph. Oh, it's different from the previous examples. Here we cannot say that it is positive nor negative. But we are sure that the graph is nonlinear. Of course, when we connect the dots, it cannot form a line. And so we can say that the direction is not positive nor negative. So in this case, it's safe to say that there is no linear relationship between the time spent in studying and scores. So the graphs that I have shown you that is graph in the XY plane or the Cartesian plane is what we call the scatter plots. So scatter plots are diagrams that are used to show the degree and pattern of relationship between the two sets of data. Your students might ask you, Ma'am, sir, what's the difference between the graphs that we already know? Like for example, bar graph, line graph, column graph, dot plot, stem and leaf graph. What's the difference between them? Okay, of course, well, the bar graph, the line graph, only shows one datum, meaning those graphs are tools for graphing a univariate data, only one. But scatter plot, it shows the relationship between two sets of data. So in statistics, the statistical tool that uses scatter plots visually is what we call the correlation. Again, correlation is a statistical technique that can show whether how strongly pairs of variables are related. So in describing correlation, we have the direction, positive, negative, or no correlation. We have the form. It can be linear or nonlinear. Or the strength, we have strong, moderate, or weak. So for the direction, it shows the pattern in the scatter plot. So we say positive correlation, just like the example a while ago, as x increases, y also increases. Negative correlation, if x increases, as the y coordinate decreases. Or no correlation, just like in example number 3, describe a data set that has no relationship between the variables. That's direction. And the form, if data points lie on or close to a straight line, we can say that the scatter plot has a linear form. Otherwise, it is a nonlinear form. So in strength, the strength of a linear correlation refers to how closely the points reassemble a straight line. So if the points lie exactly on a straight line, then we can say that there is a perfect correlation. If the points are scattered randomly, then we can say there is no correlation. So let's go back to our graphs. So here in example, so we have perfect positive correlation. Of course, it is increasing, and it lies exactly on a straight line. Here we have perfect negative correlation because it's decreasing, and of course it also lies in a straight line. But here we can say no correlation. But in real life scenario, the data cannot be perfect positive correlation. It cannot be perfect negative correlation, but somehow related to no correlation. That is why most scatter plots will fall somewhere in between these two extremes and will display a weak, moderate, or strong correlation. So here are the graphs of the strong positive correlation, the strong negative correlation, the weak positive correlation, the weak negative correlation, no correlation, and also here no correlation. So note that the strength of the relationship here was not numerically measured. The strength of the relationship here was estimated. We already seen it visual only. So we will introduce a measure of the strength of the relationship, which is called the Pearson product moment correlation coefficient. Usually it is denoted by R, which measures the strength of the linear relationship. But it is applicable only to data in the ratio or interval levels. So the nominal and the ordinal level, we cannot use the Pearson product moment correlation coefficient. So the value of R ranges from positive 1 to negative 1. So to find R, the following formula is used. We have R is equal to this formula, where N is the number of paired values. Summation of XY is the sum of the products of X and Y. Summation of X is the sum of X values. Summation of Y is the sum of Y values. Summation of X squared is equal to the sum of squared of X values. And summation of Y squared is the sum of squared Y values. So R is interpreted as follows in the following table. So here are the ranges. I put a reference here because some references might give another interpretation for R. So we have perfect positive correlation, strong positive, and so on and so forth. So let's have an example. The table shows the height in centimeter and weights in kilogram of 6 teachers. So solve for the Pearson product correlation coefficient and interpret the result. So here I will show you how to calculate manually, and later on we will use technology to support the manual calculations. So here is the solution to example number 4. Okay, all right. So again, I put the formula. So I think some students, when they see this formula, they will be shocked because it's a long formula, right? And so they will tend to generalize again that indeed mathematics is difficult because of this formula. But in order to avoid those feeling of the students, we will separate those terms here in a tabular form. Okay, so here is the tabular form. We separated the value for x and y. These are given. So x stands for the heights in centimeter, and y is the weight in kilograms. So these are given, these are given. In the formula, we need summation of x, meaning the sum of the values of x. So we sum all the values of x, meaning 160 plus 162, and so on and so forth. So we have 984. In here, the formula needs summation of y. So we sum the values of y. So we have summation of y is 357. Of course, we have x times y, meaning x 160 times 50 is 8,000, and so on and so forth. So in the formula, we need also the summation of xy. So we have 58710. And also the x squared, we refer it to the column in x. So 160 raised to the power of 2 is 25600, and so on and so forth. And the formula also needs summation of x squared. So we have 161486. And also for the y squared, we refer it back to y. So meaning 50 squared is 2500, and so on and so forth. So again, in the formula, it needs summation of y squared. So we have 21503. So as you can see, we have n here. Again, n is the number of paired values, meaning the number here is 6, not 12. Okay, so the common mistake of students, they denote n, the value of n as 12. Please emphasize to them that n is the number of paired values. So again, in bivariate data, it always comes on pairs. All right, so next is to substitute the following values to the formula. So I suggest you emphasize to the students that in solving this one, first write the formula. So in order for them to be guided. So note that in the formula, this is a common mistake of student. Summation of x squared is not equal to the summation of x quantity squared. So please emphasize to them that this is not equal. So if the student will have an equal value of these expressions, they will be wrong. And another note is the denominator of this formula can never be negative. So if the student will arrive to an answer of negative in the denominator, their answer is wrong. So this can never be negative because the domain, what's the domain of the denominator again? The domain of the denominator is greater than or equal to 0. So this can never be negative. Okay, so we substitute the values. So n is 6. Summation of xy is 58710 minus summation of x is 984. Summation of y is 357. Then divided by n is 6 times summation of x squared is 161486 minus summation of x first, we have 984, and then quantity squared times the quantity 6 times the summation of y squared, we have 21503 minus 357, which is the summation of y squared. Okay, and please tell your students not to, because some students are in a hurry to compute. So please tell them to do it step by step. So we have 6 times 5, 8, 7, 10, 710. We have 3, 5, 2, 2, 60 minus the product of this is 3, 5, 1, 2, 8, 8 divided by 6 times this one. The 984 squared is this one, and so on. So, and then we arrive to 972 divided by square root of 1035540. So the R here, or the Pearson correlation coefficient, is 0.95517. Or if we correct it to 3 decimal places, we have 0.955. Okay, so now let's interpret the value of R, 0.955. Which do you think will fall? The value of R falls in the table. Yes. Strong what, Sir Freddy? Yes, it's positive. The value of R is 0.955. So it falls in the interval of strong positive correlation. Of course, 0.955 belongs to plus 0.71 to plus 0.99. And then we can say in conclusion that the value of R is equal to 0.955 is between plus 0.71 plus 2 plus 0.99. Therefore, we can say that there is a strong positive correlation between the height and weight of the 6 teachers. Okay? So the next example, the solution to example 4, we will use technology to support the manual calculations of the student. So again, this is it. So let's watch the video.
Hi! In this video, we will use technology to support the manual calculations for the computation of the Pearson correlation coefficient R. The technology that I am talking about is the Microsoft Excel. First, we need to input the headings of the table, namely x, y, xy, x squared, and y squared. And then we put the values for x and y based on the data on example number 4. To compute for x times y, we just need to type in equal sign and then click on the first value of x times, which is denoted by asterisk, the first value of y, and then click enter. And then we drag it down. For x squared, just type in equal and then click on the first value of x, this symbol, and then 2, meaning the number is raised to the power of 2. Then click enter. And then we drag it down. For y squared, again we type in equal, and then we click on the first value of y, this symbol, then 2 for squared. Click enter. And then drag it down. Next is to input the values for here. So for n, again, meaning n is the number of the paired values. So for this example, we have 6. Summation of x, meaning we sum all the values of x. In doing this, we have to type in equal, and then the word sum, open parenthesis, highlight the values of x, and then close parenthesis, enter. We do the same for summation of y. We have equal, sum, open parenthesis, highlight the values of y, close parenthesis, and then enter. The same for summation of xy. We have equal, sum, open parenthesis, we highlight the values of xy, and then close parenthesis, enter. The same for x squared. We have equal, sum, open parenthesis, highlight the values of x squared, and then close parenthesis, enter. Lastly, for y squared, we have equal, sum, open parenthesis, and then highlight the values of y squared. And then close parenthesis, enter. Next, I put the formula for the Pearson correlation coefficient R here in order for me to be guided in the calculations of R. So in here, I separated the numerator and the denominator. So the numerator is n times summation of xy minus summation of x times summation of y. To do this, we just need to type in equal and then click on the value of n, which is 6, times the value of summation of xy, which is 58710. I put parentheses here to emphasize the quantity, minus the summation of x, which is 984, times summation of y, which is 357, close parenthesis, and then enter. So therefore, the numerator is equal to 972. For the denominator, since it is a long expression, I separated this quantity and this quantity. So for this expression, we just need to click in type in equal, and then click on the value of n, which is 6, times the summation of x squared, which is 161486, parenthesis, to emphasize quantity, minus the quantity summation of x, which is 984, which is raised to the power of 2, close parenthesis, and then enter. For this expression, we have to type in equal, and then click on the value of n times the value of the summation of y squared, which is 21503, again parenthesis, minus quantity summation of y, 357, raised to the power of 2, close parenthesis, and then click enter. Then we multiply this expression from this expression. So we have equal 660 times 1569. Click enter. So lastly, for the denominator, we operate the square root. So in Excel, square root is equal SQRT, and then click on this number, close parenthesis, and then enter. So the denominator is 1017.61. And lastly, to compute R, we divide the numerator and the denominator. So we have equal 972 divided by 1017.61. So click enter. So the value for R is equal to 0.95517. If we correct it to 3 decimal places, R is 0.955. So there you have it. We already computed the correlation coefficient. Thank you.
All right. Is the video clear? Is the video loud and clear? Okay. Thank you. So as you can see, we use the technology which is the Microsoft Excel. So I use Microsoft Excel because it is one of the famous technology that students can use to calculate this Pearson correlation R. All right, so as you can see, we arrive in the same conclusion that the value of R is equal to 0.955, which is in between, again, plus 0.71 to plus 0.99. Therefore, there is a strong positive correlation between the height and weight of the 6 teachers. All right, let's have an exercise. You can use your calculator if you have calculator, or you can use calculator in your cell phones. So the table shows the scores obtained by 12 students in the college entrance examination and their final average grades. So solve for the Pearson product correlation coefficient and interpret. So we have the solution for exercise number 1. So I just put the blanks A, B, C, D, and E. So I will call some participants to answer A, B, C, D, and E, and F, of course. So A, what is the summation of X? So I will give you 1 minute to do it. You can all add the values of X. All right, what is your answer, Sir Rani? Sir Rani, can you hear me? What is your answer for letter A? Hello, Sir Rani? All right, how about Ma'am Josefina? Yes, ma'am. What is your answer for letter A?
Good morning, ma'am.
Yes, ma'am. What is your answer for letter A?
1,261.
Okay, so the answer for letter A is
1,261.
1,261. Thank you, ma'am Josefina.
Welcome,
How
ma'am.
about for letter B? So it's under the column XY. What is your answer, ma'am Nolin Thailand? Hi, ma'am Nolin. What is your answer for letter B? How about ma'am Sir Roderick Sayod? What is your answer for letter B? Sir Roderick? How about Ma'am Jean Julio? Yes, ma'am. What is your answer for letter B? Ma'am Nolin says 7826. So the answer for letter B is 7826. So we just multiply 91 times 86. How about letter C? What is the answer for letter C? Sir Roland Nasayaw? What is your answer for letter C, summation of XY? According to Sir Redneil, it's 107,820. Is he correct? And also according to Fedi. And also Rani 12090. So what's the answer? We have for summation of XY, we have 107820. So correct, okay. So how about letter D? What's the answer for letter D? It's under the column X squared. So what's the answer for letter D? All right. Mas tindot i-chat na lang yun dahil, no? So the answer for letter B is just 115 squared. So the answer for letter D is 13225. How about letter E? It's under the column Y squared. All right. Right. It's letter E. What's the answer? So the answer for letter E is 8,100. It's just you refer it to the column in Y, which is 90 squared, which is 8,100. And finally, how about letter F? What is the summation of Y squared? All right, we have 87042. Okay. So the answer for letter F is 87042. Right? Okay, that's correct. So next, let's substitute all the summation values again to the formula. So I've written the answer here. And of course, for the students to think again, we can ask them, is summation of x squared equal to summation of x squared? Of course, the answer is no. But you can tell them why is it that it is not equal. So they can answer this one. They can compare the values here. 134949, is it equal to 1261 squared? So of course, the answer is not equal. So finally, we arrive, after we substituted the values here, we arrive at R is equal to 0.695. Okay, next. What is the interpretation of our R? Where does 0.695 belong in this table? Again, where does this R 0.695 belong to this table? So it's positive 0.695. Yes, moderately positive. Okay, so the answer is moderately positive correlation. Okay. Okay, then we can conclude that the value of R is equal to 0.695. That is in between plus 0.51 to plus 0.70. Therefore, we can say that there is a moderately positive correlation between the college entrance test score and final average grade of the 12 students. Now, because those manual calculations are too laborious, right? Meaning it takes us more time to solve it. So I will introduce another analysis or another technology, which is the analysis toolpack and equal Pearson function in Excel. So in the manual calculations, we have R is equal to 0.6953 or 0.695. So again, we will introduce using analysis toolpack in Excel and using equal Pearson function in Excel. Let us see if they arrive in the same result. So this analysis toolpack, this is found in a Microsoft Excel, is applicable to Microsoft Excel 365, 2019, 2016, 2013, 2010, and even 2007. So my version of Excel is in 2010, so I can use analysis toolpack. So we need first to load the analysis toolpack in Excel for Windows. So to show this, let's watch this video.
Hi again. In this video, I will show you how to load the Analysis Toolpack in Excel. Click the File tab, and then Options, and then Add-ins category. In the Manage box, click Excel Add-ins, and then click Go. In the Add-ins box, check Analysis Toolpack and then click OK. To check if we loaded it successfully, click on Data and then find Data Analysis. Thank you.
Okay, so if we're done loading the analysis toolpack in Excel, then we can use it in the data analysis. So let's watch the video on how to use analysis toolpack and equal Pearson function. Let me ask, is the video clear a while ago? Because Ma'am Joy said, pilit ma'am. Is the video clear a while ago on how to load the analysis toolpack? Anyway, I will share it to you. The video that I used, I will share it to you. So it's okay. So again, let's watch the video on how to use analysis toolpack and equal Pearson function in Excel.
Hello everyone! In this video, we will use the analysis toolpath and equal Pearson function to solve for the Pearson correlation coefficient R in Excel. First, we need to input the values of x and y in exercise number 1. So we have x and then y. First, using the analysis toolpath, click on Data and then Data Analysis. Click on Correlation. In the input range, we highlight the values of x and y. And in the output range, we just click here. And then click OK. So we have the output 0.695284. So using analysis toolpath, R is equal to 0.695284. Next, we will use the function equal Pearson. So in here, we just type in equal and then the word Pearson, open parenthesis. As you can see, we have array 1 and array 2. Array 1, let's highlight the values of x, comma. Array 2, let's highlight the values of y. And then close parenthesis and then click in enter. So using equal Pearson, the correlation coefficient R is equal to 0.695284. So using analysis toolpath or using Pearson, they both have the same result. Thank you.
All right, is the video clear? Okay, yes. Yes, okay. So as you can see, according to it's the LIRA, right? It's easier than the manual calculation. So again, using the manual calculation, that is the result of R. Using analysis toolpaths, it's the same result. And using Pearson function, of course, it's the same result. Of course, Sir Roland, I will share the video later. Okay, and then we arrive in the conclusion, again, that the value of R is between this range. So we can say that there is a moderately positive correlation between the college entrance test score and the final average grade of the 12 students. All right, how about exercise number 2? You solve it using the Microsoft Excel, using the analysis toolpath, or the equal Pearson. So I hope that you already downloaded the hands-on Excel in LMS. So I'll give you 5 minutes. If you have Excel, those who have Excel, you can use it. All right, timer starts now. Can I just confirm who among you here downloaded the Excel file? It's okay if you did not download it yet. Okay. So Ma'am Josefina downloaded it and Fedi. Okay, you can use it if you are using laptop. You can calculate the Pearson correlation coefficient R. So if you have already the answer, you can just type in the chat box your answer. Yes, you can use sheet 2 or sheet 1. Sheet 1 is for the manual calculations, but sheet 2 is for that equal Pearson. So here in this exercise, I just need the correlation coefficient R. Oh, some already arrived an answer. It's up to you if you tell your student what decimal places to correct. So here we correct it to 3 decimal places. All right. Ma'am Jane. Ma'am Jessa also. Ma'am Mary Joy. Oh, and then Ma'am Cybel Joy, Fritzy May. Ma'am Jessa may also arrive her answer to correlation coefficient R. Also Ma'am Michelle, which is longer. It's okay. And also Ma'am Josefina. All right. And also Ma'am Nolin. If you're gonna try it now, you can try it later. Of course, Ma'am Mary Rose, 0.94412. All right, so what's the answer? So the answer is, the value of R is 0.944, which is in between plus 0.71 to plus 0.99. Therefore, we can say that there is a strong positive correlation between the ages and the systolic blood pressure of the 12 patients. So thank you for your participation. Now, let's recap the conclusion made in example number 4 and in exercise 1. So in example number 4, we have there is a strong positive correlation between the height and weight of the 6 teachers. And then in exercise number 1, there is a moderately positive correlation between the college entrance test score and final average grade of the 12 students. So as you can see, here the conclusion is there is a positive correlation, there is a moderately positive correlation. Now we will ask ourselves now, is the correlation or relationship statistically significant? Meaning, can we use the result in a wider or in general manner? That's the meaning of when you say statistically significant. So to answer this question, we have to I have to present some of the bivariate correlations in the analysis. We have for the quantitative variable, meaning in the ratio or interval level of the variable, we can use Pearson correlation or the Kendall-Stau-B correlation. In the ordinal level, it is applicable to Spearman's rank order correlation, and for nominal level, which it is chi-square. But again, we will focus on the Pearson correlation or Pearson product moment correlation in this lecture. But before we use the Pearson product moment correlation, there are assumptions that we need to meet. So assumption number 1, the two variables considered should be measured at the interval or ratio level. So here, so we will use the variable in interval or ratio level only. So if the variable is in the nominal or ordinal level, we cannot use the Pearson product moment correlation. And then assumption number 2, there is a linear relationship between the two variables. So the graph, the scatter plot should look like this, not this one. Next, assumption number 3, there should be no significant outliers. Outliers are those hindi naiiba sa mga points here. So here's the comic, hey, what's this doing here? So that's the outlier. Assumption number 4, the variable should be approximately normally distributed. So last Tuesday, Sir Agua discussed about the normal distribution. So in Pearson, the variable should be approximately normally distributed. So not this one, nor that one, but this one, approximately distributed. So for today's lecture, we just assume that the data we will be using follows the normal distribution and follows all the assumptions. So we will introduce the p-value method, or short term for probability value. So what is this probability value? So it tells us if the result of the study is statistically significant. Evaluates how well your data rejects the null hypothesis. Successfully rejecting this hypothesis tells us that the results may be statistically significant. And then we will compare it to the level of significance, the probability of rejecting the null hypothesis when it is true. So the scenario here is we will construct hypothesis, the null and alternative hypothesis. We will assume that the null hypothesis, which is that there is no relationship, is true. And then we will find evidences or facts to reject that there is no relationship. So the value of the level of significance, it's the rule of the thumb. We have 1%, 5%, or 10%. But usually when I read articles about education, it uses the 5%. But in medical, they use 1%. So again, it's the rule of the thumb. So what are the conclusion? If the probability or the p-value is less than or equal to alpha, then we can say reject the null hypothesis. But if it is greater than alpha, then we can say that there is no enough evidence that we reject the null hypothesis. So do not reject the null hypothesis. So what are the steps? Of course, we state the null and alternative hypothesis, and then determine the significance level, then compute the p-value. Again, we will use analysis toolpack in Excel to compute the p-value. Then we draw a conclusion. So for example, number 5, a group of researchers surveyed 20 students. They want to find out if there is a significant relationship between the students' allowance and their scores in examination. So the table shows the data that they have collected. Using a 0.05 level of significance, what conclusion can we make? Assume that the assume normality over the population. So we need first to meet the assumptions. So we assume that it follows a normally distributed pattern. All right, solution to example 1. First is to state the null hypothesis and the alternative hypothesis. So we can say that the null hypothesis is there is no significant relationship between the allowance and the scores of the students. And while the alternative hypothesis, we have there is a significant relationship between the allowance and the scores of the students. So for step 2, of course, we already identified the level of significance, which is 5% or 0.05. Okay, then step 3, we use the analysis toolpack to compute the p-value. So let's watch again the video on how to solve the p-value using analysis toolpack.
Hi everyone! In this video, I will show you how to compute the p-value using the analysis toolpack in Excel. First is to input the data. Then click on Data. And then Data Analysis. We will not use the correlation because it does not show the p-value. Instead, we will use the regression. So click on Regression. In the input y range, click on the y values. Don't forget to include the label scores. And then for x range, click on the x values. Then click on Labels. And then the confidence level is 95%, so it's okay because our level of significance is 5%. And then for the output range, we just click it here. And then click OK. Okay, let me expand it. And then we go to the column of the p-value. So the p-value now is 0.97681. Thank you.
Okay, is the video clear? Okay, all right. How about the others? Is the video clear? All right, Sir Brian, yes. All right. Okay, so again, we arrive in the p-value of 0.97681. 681. Yes, Ma'am Nolin, it's clear? Okay. So we can say that the p-value is 0.97681. So since the p-value 0.97681, of course, it's greater than the level of significance, which is 0.05, then we can say we do not have enough evidence to reject the null hypothesis. So our conclusion here is there is no significant relationship between the allowance and the scores of students. Okay. For exercise number 3, again, this is found in the hands-on Excel that I gave you. So please compute the p-value there. I'll give you 5 minutes to compute. Oh, Ma'am Josefina arrived quickly to an answer. How about the others? Right, there are 2 participants who already arrived an answer. How about the others? Okay, there are already 4 participants. Sir Jeremiah answered a complete enumeration of the p-value. Again, it's up to you if it's corrected 3 or 4 decimal places. But of course, you tell your students about it. All right. All right. Okay, some are computing, some already arrived to an answer. Okay. So again, for those who cannot compute today, you can compute it later. All right, so we use the step-by-step. Using a 0.05 level of significance, what conclusion can we make? So again, assume normality over the population. So step 1, of course, we construct the null hypothesis and the alternative hypothesis. So the null hypothesis is there is no significant relationship between the height and weight of the students, while the alternative hypothesis is there is a significant relationship between the height and weight of the students. So our alpha again is 0.05. So the answer is the p-value is equal to 0.001589 using the analysis toolpath. And as I scan, you are all correct. So since p-value 0.001589, of course, this is less than the level of significance, which is 0.05, then we can say that we can reject the null hypothesis. And so there is a significant relationship between the height and weight of the students. So let me remind you of the performance standards in DepEd, since statistics and probability belongs to the most essential learning MELC of DepEd. So let me remind you that the learner should be able to perform correlation on real-life problems in different disciplines. So with all of that, thank you for listening. I will give back to the facilitator, Milburn. Hello, Milburn.
Okay, so sorry. Okay, so thank you, Mrs. Apdo, and without further ado, lakas maka-vlogger, no? Okay, so without further ado, let's proceed to the Q&A. So you may uh, ask questions through your chat box. Okay. Chat box.
Are there any questions? Again, the video that I used, I will share it to you via Google Drive.
Mana ni? Wow, nakita ko. Okay, connect ko siya. Ayan na lang, ayan na. Ara. Like question.
Are there any questions? Or if you have questions in mind later, you can just, if you are too shy to comment your question, you can just PM me later.
Okay, so I guess participants doesn't have any queries about the topic because our speaker is very excellent. Okay, so uh, let's proceed to another announcement. Okay, so let me have a screen share. Icon ha. Okay, here's the Zoom. Then screen share. Okay, so announcements. The assessment and evaluation of this webinar can be accessed through the MASA lms.carso.edu.ph website. Your certificate will be activated once you have completed all the required tasks. And please be advised to change your profile at SSU LMS account before completing the task. The name you registered in the platform is the name that will appear on your certificates. And number 4, the completion of the lecture, assessment, and evaluation for each webinar is time bounded. So you are only given until midnight of the conduct of the webinar to complete these. Access to these activities will automatically be disabled beyond midnight. And please follow the page, Facebook page, CSU Extension PASA page for more updates about webinar series. Okay, so for the trailer, so next webinar is on August 3 to 6. We have 4 lectures here: limits and continuity, application of derivatives, optimization, related rates, the indefinite integral, and lastly, we have the definite integral and area of a region bounded by curves. So that is under basic calculus. So that would be the last webinar in senior high school mathematics. So once again, I am Milburn Omakalos, and thank you for attending this webinar. Okay, so before we end this webinar, can we open the camera for the class picture? So now mga handsome and beautiful participants. Okay, so
What's the cue, Sir Milburn?
asa lang, wait. Webinar. Okay, so smile. 1, 2, 3. Smile. Then wait. Salang ko sang ikuan ha, ako sang i-paste. Another set. Please smile. And wait. Ako sang i-paste. Another. Please say cheese. Okay. Okay, wait. Control V. And another. Say cheese. Okay. Another. Wait. Next. Say cheese. Oh. Murag wala naman ang uban, wala na camera. So last. Say cheese para sa noun sa facilitator. Okay. So that's all for today's webinar, and you may now leave this Zoom meeting. Thank you, everyone.